right, so, part 2 of chapter 18. Let's talk anterior pituitary. The hormones coming from your anterior pituitary are going to be proteins, glycoproteins, or polypeptides. And as I said before, they're labeled as tropic hormones. So they're transported via the cardiovascular system. We talked about this last chapter when we said that the cardiovascular system carries hormones to some destination in the body. Half-life for most of these hormones is going to be in minutes. It's not going to be hours or days. They do bind to membrane-bound receptors, which makes sense because with proteins, glycoproteins, and polypeptides, we're talking about things that are water-soluble. If they're water-soluble, they have to be transmembrane proteins. They have to bind to something outside the membrane. Most hormones are going to be secreted by their own kind of separate cells, their own subset of cells in the anterior pituitary. So, growth hormone actually targets most of the tissues in the body. So it stimulates the growth of most tissues. So growth hormone is actually really important when you're a kid and you're actually still growing. It's important in the regulation of nutrient levels as well as the regulation of metabolism. It increases the movement of amino acids into the cells. It increases lipolysis, lipo, fat, lysis, breakdown. Okay, so lipolysis. It increases fatty acid release. Again, we're talking about fuel. We're putting fuel into the blood. From the adipocytes, remember adipose, fat, cytes mean cells. It also increases glucose synthesis in the liver. What is glucose? It's a fuel source so that we can actually make more ATP. So again, if you look at what it's doing, it's increasing the amount of fuel in the body available. Thyroid stimulating hormone, its target, who knew? The thyroid, but it does cause the release of thyroid hormone. That's what it's doing. It's causing the thyroid to release thyroid hormone. Adrenocorticotropic hormone actually does target the adrenal cortex, as we talked about. It increases hormone secretion from the adrenal cortex. LH and FSH, they're gonadotropin releasing hormones, right? So gonado, they're going to target the gonads. When it comes to the testes and the ovaries, we're talking about causing the formation of sperm or the formation of eggs. It controls the production of reproductive hormones as well. So again, gonad specific. The ovaries, it increases the amount of estrogen and progesterone that they are producing, whereas in the testes, it increases the amount of testosterone being produced. Prolactin. The mammary glands and the ovaries are the targets. In the female, milk production in the mammary glands goes up. The ovaries also start to increase progesterone secretion. In males, we don't know because the receptors that you would expect to be there aren't there in the males. So we're not sure if it does anything specific there. Something else with the adrenal cortex and adrenocorticotropic hormone. It does influence other things. So for example, it influences lipotropins. Lipotropins, there we go, beta endorphins, and melanocyte stimulating hormone. Lipotropins target fat tissue, and they increase fat breakdown. So lipotropins have one job: go to fat tissue and cause fat breakdown. Beta endorphins, we only know of one target, and that's the brain, and it is actually a painkiller in the brain. It inhibits growth hormone releasing hormone as well, which is one of those really, but it really does. let's see. I'm sorry, gonadotropin releasing hormone. Can't take me anywhere. And then so beta endorphins. Beta endorphins are one of those things that when we are exercising, we get that high, quote unquote, from exercising. One of the reasons we get that high is because of beta endorphins. Beta endorphins kick in and we get that feeling of basically being given painkillers because that's what it does. The target is the brain because the brain is what actually causes us to feel pain. It's the thing that actually interprets the information saying, hey, we're in pain right now. Now, melanocyte stimulating hormone. What could possibly be the target? Melanocytes. And it actually causes an increase in melanin production, producing darker skin. Now, there is a disease called Addison's disease. Addison's disease happens when your adrenal gland actually overproduces its hormones. And most of the time, people who have Addison's disease will go to a doctor and say, I feel terrible, because when it comes down to it, the adrenal gland isn't just working on melanocyte stimulating hormone, it's doing other things. And they feel terrible. Their body feels terrible. They are not doing well. Another kind of symptom is they like salty foods. Now, I'm not saying like, oh, I like popcorn. I'm saying that they're sitting there with a Morton's can and a spoon and just shoveling salt into their mouth, because one of the side effects of having way too much adrenal gland hormones is you leach salt out of the body. In other words, you're losing mass amounts of salt. But this is the problem. Doctors see them and they're tanned and they look healthy, so they ignore them. They think that they're just being a hypochondriac. They don't really realize that there is seriously something wrong. So these people feel terrible, but they look great. They look like they just came off of a beach, because one of the side effects is that they've got this overstimulation here of that melanocyte stimulating hormone, causing their skin to look tanned. And yet the other hormones that are coming out of that adrenal gland are basically just ruining the rest of their body when it comes to how they feel. So that's just an example of how things can kind of go wrong. Now, the thyroid gland. The thyroid gland actually sits right below your voice box, kind of looks like a butterfly. So it's the lateral upper portion of the trachea, just inferior to the larynx. So it's just below your voice box on your trachea. It's one of the largest endocrine glands at about 20 grams. It is very highly vascular with numerous follicles whose centers are filled with proteins called thyroglobin, and they're produced by follicular cells. So if you look here, or not, if you look over here, you can see that these kind of look like bubbles. If I were to blow bubbles onto a plate, they actually are bubbles. These are follicles, and they're made up of follicular cells. And in this space here, in this space, in this bubble, you're going to have thyroglobin, okay? You also have cells that are right next to these follicles, and these are called parafollicular cells. Para means side by side, like the word parallel. So parafollicular cells right next to the follicle, okay? The follicles actually store large amounts of thyroid hormone as part of thyroglobin, T3 and T4. The parafollicular cells produce something called calcitonin. So, triiodothyronine and tetraiodothyronine. If you go back to the last chapter, I showed you what these look like. You're basically taking a tyrosine, an amino acid tyrosine, and you're adding iodine. In fact, this right here is one of the main reasons why we have iodinized salt from the grocery store, because we need the iodine so that we can make this hormone. So triiodothyronine is called tri because it actually has 3 iodines attached to it. It's 10% of the thyroid product. Tetraiodothyronine has 4. Tetraiodothyronine is more commonly known as thyroxine, and it's 90% of the thyroid product. If we have excess thyroid hormone, it's stored within those follicles that I just showed you. Thyroid stimulating hormone will cause the release of both T3 and T4 from the follicles. The major component of them, like I said, is iodine, which is why it's so important to have it in your diet and why the government decided to start adding it to salt. These are also lipid soluble hormones, so they're not going to be found without being bound to something. 70 to 75% in the blood has to be bound to a transport protein called thyroxine binding protein. We talked about the lipid soluble hormones being bound to a transport protein. This is an example. What this does for us is within our blood, it creates a reservoir of T3 and T4. 33 to 44% of T3 is actually converted to T4 in the tissues because T3 is a major hormone that interacts with the target, and it's actually several times more potent than T4, so I don't need a lot of T3. It is rapidly metabolized, so it's rapidly broken down, and it's excreted as part of the urine or part of the bile. So, we've got the follicular cells in the thyroid. We've got the parafollicular cells in the thyroid. The follicular cells are going to be making our thyroid hormones, T3 and T4, which target most cells in the body. It's essential to the normal process of growth and maturation. Again, if you've got a kid in their formative years who's growing up and they do a test and find out that there's not enough thyroid hormone there, they're going to start supplementing because you need this. Again, as far as metabolic rate goes, it increases fat breakdown of sugar, fat, and protein in your body. It increases sodium potassium pump activity. And if you think about that, that's burning ATP. And it can alter the number and activity of mitochondria. Remember, mitochondria are responsible for making your ATP. So if you've got glucose and you've got a huge number of mitochondria, you're going to convert that into ATP a lot faster. People that have hypothyroidism don't make enough of this, and they tend to have a very slow metabolism. They can eat like a bird and they still will end up gaining weight because their body isn't actually using that the way that it's supposed to. The other thing that happens is that they tend to actually be tired all the time. They really are just, they can't get enough energy out of their food to keep their body going the way that it should. The motor's just not running like it should. They tend to also have dizzy spells and heart palpitations. How do I know this? Because I have it. I do have hypothyroidism, and the issues that I face are those issues. So what did they do? They gave me oral thyroid hormone. I take it as a pill in the morning so that I actually have enough thyroid hormone to keep my motor going the right way, my metabolism up the right way. The opposite end of that would be hyperthyroidism. Hyperthyroidism, these are people whose metabolism is really, really fast. They can eat anything and they don't actually gain any weight because their body burns through it so fast. Now, I'm sure there are people probably going, that's the disease I want. No, you don't, because the other part of that is you get something called a goiter. And basically, your neck swells up like a bullfrog. Not a sexy look, okay? The other thing that happens is your eyeballs bulge out of your skull to the point that even with some people, they can't close their eyelids all the way because their eyeballs are so pushed far out. So what do you do for them? Because you can't give them medication. Normally what they will do is they will irradiate the thyroid. Now this is the problem with that. It's not an exact science. So sometimes they kill too much of that hyperthyroid. And when they do, they literally take them from being a hyperthyroid suffering person to a hypothyroid suffering person. And then they have to be on medication. So that's kind of interesting. Now, the parafollicular cells release something called calcitonin. Calcitonin actually decreases osteoclast activity. Remember, osteo means bone. Clasts are the cells that break it down. Okay, so they're basically decreasing the amount of bone breakdown that's happening, and they lengthen the life of the osteoblast. Now, osteo again means bone. Blast. Blast means to build. These are the cells that actually build the bone matrix. So the ultimate result of that is you're going to see bone deposition. You're actually going to see bone matrix being built. Okay, so your bones start basically having more matrix deposited within them. It also decreases the amount of calcium and phosphate in the blood because that matrix is made out of calcium phosphate. So we're taking calcium and phosphate out of the blood and putting it into the bone. So the parathyroid glands. Parathyroid glands. Remember, para means side by side. So there's the thyroid. All I've done is I've flipped this around. So the trachea is in front here, and we're looking at the esophagus back here. So literally, it's like looking at somebody from the back of their head. Okay. See these little yellow M&Ms? There are 4 of them, actually. That might not be the best way to highlight that. These 4 little M&Ms here. These are the parathyroid, and they come in pairs. Dun, dun, dun. They're 4 small units, usually embedded in the back of the thyroid. Now, I'm not going to lie, I've seen or I've read about them not necessarily being this perfect on the thyroid. So just so you're aware. There are 2 cell types that we have inside of the parathyroid, the chief cells and the oxophils. So, chief cells, oxophils. We have no clue what oxophils do. We know that they are different. We know that they're located there. No clue. Okay, it's one of those unknown things that hopefully within the next few years we'll figure it out. But right now, we don't know. Chief cells, however, secrete parathyroid hormone. Who knew the parathyroid released parathyroid hormone? Now, parathyroid hormone actually targets several tissues: the bone, the kidney, and the small intestine. So, the osteoclasts, we talked about the fact that the osteoclasts break down bone, right? It increases their activity. So I'm going to start breaking down that bone matrix more. It also causes reabsorption of calcium in the kidneys and the small intestine. When the kidneys are going through and filtering your blood, basically parathyroid hormone goes to them and says, hey, do you have any calcium in there? And if it says, yeah, it says, bring that back. So we reabsorb calcium from there. It goes to the small intestine, basically says, hey, you know that food that you're digesting? The small intestine says, yeah. Is there any calcium in there? Yeah. Bring that in. So we start absorbing calcium from the food that we're eating. It also increases vitamin D synthesis. Remember, vitamin D has to do with calcium absorption in our body as well. So ultimately, all of these things, every single one of these things that I just mentioned up here, are going to increase the amount of blood calcium. Where calcitonin brought it down, parathyroid hormone brings it up. Okay, so we're getting more calcium in the blood. There's an increased blood calcium level.